without acquiring the necessary background data, I think that's irresponsibility and just pushing the blame onto other people by using naughty words to try and frighten the children.
Thanks, Tim. Have you got any comments to make?
Well, I'll come in on the... I mean, I agree. What Tim has said is that we don't have sufficient data. And so what we want more information, particularly information with depth. But my comment would be about the health effects. We already know that the releases from Hinkley Point, and these include particles of radioactive material, enriched uranium, and I have a table here from the United Nations Scientific Committee, which lists the particle releases from Hinkley Point. So there's no argument that these nuclear sites release radioactive particles, and you will have been given a handout that shows details of particles in the mud, in this case from Sellafield, measured by my laboratory, and you can see in the top left-hand corner here, these are mud cores, and what you can see is that the particles, and they show themselves as bright splodges here because they're irradiating photographic film. They go down quite a way, they go down quite a depth. So taking samples right from the surface doesn't tell us what's in this mud material. This is 330,000 tons that are going to turn up to a venue close to you, a few miles away here on the coast. And then that will be brought ashore by wave action and by what's called sea-to-land transfer. These are all well-known mechanisms, and so people in this area will inhale these particles, and then they'll end up inside them, like the picture that you have here in the bottom right-hand corner here of these radioactive particles in an edible mussel. And so what I'm saying is that bananas don't contain radioactive particles like this, and your garden certainly doesn't contain radioactive particles like this. So these particles are capable of producing a lot of damage to local cells. Now, if you take the normal natural background radiation dose, the external radiation and the internal radiation and so on, this provides you with 1 hit per cell per year. There are a lot of cells in your body, and a number of scientific studies that have shown that the actual impact of a radioactive particle on your cells will be 1 every year, and that's usually repairable. But that's not the case if you end up with one of these particles inside you. You'll get lots and lots of hits in a very short space of time. In fact, this picture here is a photograph that I took a few weeks ago, and you can see that there are 40 hits there who occurred in a very, very small volume of material in a very short space of time. That was developed over a day or two. So the health effects are significant. We've found health effects downwind of Hinkley Point, and I've written a scientific paper. It's been published in the peer-reviewed literature showing that these substances do cause cancer, and they will cause cancer. It's permitted to dump them over here off the coast of Cardiff.
Richard, have you got anything to add to that?
Only to emphasise a couple of points that Dr. Busby has just made. The hits from the bananas, since if they want to talk about bananas, maybe we should talk about bananas. Dr. Busby has talked about the natural background giving you 1 hit per cell per year, which is usually repairable. The body has repair mechanisms which sort out damage of that nature pretty successfully. Now, the dose from the bananas is part of that natural background. You don't actually get any additional dose from eating a banana because your body is largely composed of potassium-40, which is slightly radioactive. Life on Earth has evolved in an environment which contained potassium-40. The second, so it's 1 hit per year, including the potassium-40, easily repairable. The point about we can say something about the numbers in this yellow image on the screen, which is on the page, which is a photograph taken looking down a microscope at, I think, 200 times magnification. What you see there is, as Dr. Busby said, about 40 hits. It was actually 40 hits in 20 hours that this sample was exposed to the plastic for 20 hours. So that's 40 hits in 2 hours. And actually, what you're seeing there is only 1/6 of the decays from that radioactive particle. So that would be 300 hits in the 40 hours. So that would be, if that were lodged in your lymph nodes or in your lung, that is steadily irradiating the cells in the immediate vicinity of that particle. And we know that cancer starts with damage to a single cell. We know that genetic malformations start with damage to a single germ cell. This rate of irradiation is going on, hitting small, very small volumes of cells on and on and on, indefinitely, every day, for as long as you live.
Okay. Do we have any questions?
Why is it, do you think, that despite the points that you've made, which appear to suggest that there is genuine cause for concern about health impacts, that public bodies like the Welsh Government and NRW are resistant to the kind of arguments that you're putting forward? What's this all about?
Okay, can I just to repeat the question? I was Martin Shipton from Media Wales, because the viewers sometimes can't hear the questions. So the number that really was, why is there resistance from the Welsh Government and Natural Resources Wales to address the concerns that are being raised here?
Well, there are two reasons. The first is the obvious reason that you'd expect us to say, which is that there's an enormous amount of money riding on this. There's political developments relating to nuclear energy, huge amounts of money involved there. There's also the military aspect, because these nuclear power stations are also used to produce tritium and plutonium for weapons. And so the military are quite involved in all of this. And also the use of depleted uranium weapons also pivots on this idea of how dangerous these amounts of radioactivity are. So the first is that's the obvious answer. But the other point about this is that this evidence has really only emerged very strongly in the last 5 to 10 years. And and the inertia associated with large organizations that are responsible for regulating the exposures is immense. It's absolutely immense. And the inertia of the scientific, if you like, the scientific community is also immense, because people who've lived with the idea that this stuff is okay, or not okay, but not terribly unsafe, these people have become professors. And so there's a sort of inertia associated with the scientific. But this is changing, because I gave a talk to, well, not a talk, I gave evidence to the Swedish Environmental Court in September of last year, and they were advising the Swedish government about whether or not they could go ahead with the construction of a high-level nuclear waste facility at Forsmark in the north of Sweden, and millions of pounds have been spent on this development, and following my evidence to the Environmental Court in Stockholm, these are 8 judges, they concluded in January, just recently, 3 weeks ago, that they were not going to permit this to go ahead. And so this development, which is like a gemstone development for the nuclear industry, it's like how we are going to get rid of the nuclear waste, was kicked out by the Environmental Court. So, and if you go into court, and I've done a lot of court cases in America on these issues of the dangers of internal radionuclides like these particles, we always win the case. What happens is the case is settled, because the evidence that this is a problem doesn't want to get out into the media. So we would say, I would say that those are the two reasons. First of all, there's if you like, the Kuhnian sort of scientific paradigm change inertia associated with any revolution in science. But in this case, the revolution is associated with huge amounts of money and influence and power associated with the development of nuclear and all the military aspects of this.
Chris, can I add to that, please? The other thing is that you have this orthodoxy that Chris has referred to within the establishment, but also then that orthodoxy. Where do you get your teachers of nuclear science from at the university? From the industry and from people who have professional qualifications. So there's a cycle there. So everybody new is taught what everybody old knew. And if you come along with new information, then that is very difficult to shift into that and get that heavyweight, long-established orthodoxy to change its view. And then the second thing is that, of course, when governments allow themselves to be persuaded to engage in nuclear projects, then you need regulators and you need advisors. Where the hell are you going to get them from? except from the nuclear industry. So then you have people like we three visitors to this panel who proffer an alternative view about what is happening in terms of health effects, or in my case, the marine behavior of radioactivity. And the orthodoxy finds it extremely difficult to accept. The government advisors who were all taught in that orthodoxy say to the government, no, these fellas, they're all lunatics. They're not following the orthodoxy. They don't know what they're talking about. But of course, as we follow science through, you can look and see that science does indeed evolve, and it has to engage with new ideas, and it has to change its basic positions about what is what and what is not what. Now, originally, when discharges to sea were first commissioned in the 1950s, there was a mad rush to produce a weapons program, get on with it, start producing plutonium and refining plutonium out of Sellafield, etc. Nobody, because we're in the 1950s and we're still hanging over from the end of the war, there had been extremely restricted and cut back oceanographic research on the way oceans behave and the way pollutants behave in the marine environment. There had been no fieldwork research prior to 1952 about the way marine radioactivity behaved in the sea. Nonetheless, they said, right, okay, we'll come up with a hypothesis. The hypothesis is everything that's dissolvable will dissolve to infinity in the vastness of the sea, and everything that isn't dissolvable will attach to sediments and fall to the seabed attached to sediments off the end of the pipelines. Well, any fool can look at the official monitoring now, which is being reported for the Bristol Channel, and you can see that Hinkley-derived radioactivity is all over the Bristol Channel. It's in the sediments, it's in the fish, it's in the seafoods like the seaweeds, and certainly studies elsewhere. We haven't had any on the South Wales coast, but we've had 3 studies of sea-to-land transfer along the Welsh coast, all of which have demonstrated that marine radioactivity from man-made sources is transferring from the sea to the land, landing on food crops grown in the coastal zone. People are eating those food crops and therefore acquiring a dose that way. It's logical to assume that if that is happening, then radioactivity from the sea is airborne. Coastal populations will be breathing it in. These are issues that we have raised through the Senate Petitions Committee on this particular campaign here. We're still waiting for answers and comments and input. We don't want to be told, it's no good to the public to be told that we are irresponsible and alarmist when we're asking very simple, very basic and very righteous questions.
Really, I've got a question for the media more than anything else, because I'm not saying these guys are absolutely correct, but clearly they're raising issues, and the problem that I've got is to have been unable to have got answers from September last year, and for the whole of the mud, the whole of the area where the mud is going to be dredged up to 3 meters down, there have been only 5 samples, 5. Beneath 5 centimetres for 2000, back in 2009. And the raw data from those samples no longer exists. So all I'm saying, and I think all the public is asking really, is why not test the mud? You've heard the point of view from these gentlemen here today, and Natural Resources Wales say something different. The Minister says something different. Okay, fine. I'm not saying who's right, I'm not saying who's wrong. Test the mud. That's reasonable. And we're in a situation now where they're unwilling to test the mud. I don't understand why.
Where is the mud currently?
It's still on the seabed off Hinkley at the moment, because they can't store it. They've been told not to store it on land. Nobody wants it on land, and nobody seems to want it on the English side. It seems it's got to come over here and be chucked into Welsh coastal water, so it's still in the sediments at the moment.
What's the alternative? What's the alternative means disposal?
Well, that's a very interesting question, isn't it? Are there different ways of actually dredging? Because I mean, really, what we're doing, what they're doing, is taking the sediments out in order to put pipelines and water intakes in. Now, there may be different ways of dealing with that. There may be appropriate times of day or year in which to do the dredging, because summer is the time when most of the coastal accretion, the build-up of sediments on the coast takes place. So anything that you put into the sea during the summer is far more likely to end up adding itself to a beach rather than being eroded and taken out to sea. So that might be a mitigating factor, different time of year, different techniques. Maybe look for a more suitable disposal site, perhaps an on-land enclosed site where you can monitor and control the material. It's not really my problem. Those who are proposing the proposal need to find safe options, and plainly, if they do anything other than what they're proposing to do, it's going to cost them a lot more money. It's really cheap, relatively speaking, to dredge it up, put it in a dredger, take it over to the Welsh site and chuck it into the water, and you're done. It's finished. It's over. It's gone.
Can I just touch on cost as well? Because we're talking a multi-billion-pound development, and to test this material thoroughly, you're looking at less than £100,000. A ridiculously small sum in comparison to the overall project. So, I think it's incumbent upon everybody to be asking, why not test the material?
Could I ask, Gareth Hughes, freelance journalist, you provided us with photographic evidence here of radioactivity in mussels. Is it the main source of ingestion by the human of this radioactivity, or is it just an example that you're providing?
I would say that it's the main dangerous source. That there is a lot of ingestion of radioactivity naturally, but the problem is that there have never existed up until recently these radioactive particles. That they began after the weapons fallout testing and the nuclear power and the splitting of the atom. So throughout evolution, there have never been these particles in the environment. They didn't exist.
The other question, certainly I don't know the answer. Are there any kind of tests made before food of this kind enters into the food chain?
No. What they do is they test the overall radioactivity. This is the concern that we have had for a long time, is that if you take a Geiger counter and you wave it over a surface, it will tell you what the dose rate is. So it will give you an average quantity of the radioactivity. What it won't do is tell you whether these little hot particles are present in the material. And that's quite a tricky thing to do. You can do it, but it's expensive and it's tedious, takes a lot of time, and you can work out how many particles there are in any sample. But as in fact these people have done, but nobody does it routinely. No.
Can I just finish? The other area then that is of concern, which you actually said in your presentation, is how far down the coast will it go? Because in Swansea, of course, there's a tradition of actually harvesting seaweed for lava bread, and also just further up the coast, of course, that you have the cockle industry of based in Tennessee and that area. Are we talking about those areas being affected, and if so, does that actually kill off could potentially kill off an industry that we have?
Those particles are already there. They're there as a result of Sellafield. They're there as a result of the operation of the various nuclear sites along the Bristol Channel. And the study that I did for the Irish government in 1997 to 2000 examined the rates of cancer by distance from the sea in Wales. It wasn't down in South Wales. We did Mid and North Wales, and we found that there was a 30 to 40% excess risk of cancer along a coastal strip that was about 1 kilometre deep, and then it fell right down very rapidly. And that's also the same trend with distance of plutonium particles measured by Harwell, by the Atomic Energy Research Establishment in Harwell, who put up muslin screens. And they intercepted the sea spray and the material coming from the sea, and they measured these. And this was all published in the 80s, so it's well known. It's called sea to land transfer. So the two routes of exposure to these particles are one where you eat the cockles or you eat the mussels or whatever, because they filter the water. That's what they do, so they're quite efficient at filtering these particles out, and they end up inside them. So then when you eat them, they end up inside you. And the other route is the airborne inhalation route, which is also well known. And that's why there is an excess risk near the sea, and that's why we found an excess risk of breast cancer in Burnham-on-Sea, just downwind of about 6-7 miles downwind of Hinkley Point. And we did another study at Bradwell Nuclear Power Station in Essex, where there's a lot of mud, found the same thing, a doubling of risk of breast cancer there. Breast cancer is a very good, very good indicator for these sorts of exposures. So the answer is we're already in that territory. And what we're saying about this mud is that it's going to make it worse. It's going to resuspend material that's kind of happily locked up in the mud of Hinkley Point. And it's going to take it up, and it's going to do this with it. And then the Severn estuary has tremendously powerful tides, and it just keeps everything in suspension all the time. So if you go across the bridge to England, you'll see that the water of the Severn estuary is always brown. It's always brown. And the reason is because the tides roar in and they roar out, and they stir all the sediment up, and about 80% of the material in the which would have been on the bottom of the Severn is always in suspension. So whenever there's a gale of wind and there's those white caps and water starts to be splashed around, that stuff comes up into the air, and it then gets blown ashore. And so all along that coast, I mean, I've done some cancer studies of that South Wales coast, and the increased rates of lung cancer are highest. The rates of lung cancer are highest along the coast, along that bit. Right the way up into the Severn estuary.
Alan Abbott from BBC Wales. This is a question I never thought of asking in Neil McAvoy press conference, but do you eat mussels?
No. No, I have to. I tell you once though, when I was in Carlingford.
For this very reason.
Yes. But I was in Carlingford in Ireland in 1998 talking about this very issue, because the Irish Sea is very contaminated, and that stuff goes across to Ireland. And Carlingford Lough, they have oysters, and so I was talking to the Irish government about this. There was a big meeting, and afterwards some guy came up to me and said, "If you eat those oysters," I was with some friends there. I was with the mayor of Drogheda. We were in a restaurant, and he was saying, "If your man eats any oysters here, he's dead." So it is, and also that lost a lot of money. I remember I did an interview on the Irish radio, and they said that it wiped a huge load of money off the Irish fishing industry. But look, it's not my fault. All I'm doing is I'm saying that this is the evidence, and it shows that these things are dangerous because of these particles. The particles are not measured. Nobody measures the particles. They just measure average radiation. And something should be done about that, because people are dying.
Owen Phillips from ITV Wales. So NRW say the risk here is quite low. So for you guys, how high is the risk if this mud or this silt gets dredged?
I think it's a question as well about the kind of testing done. So what is the risk of the mud, Owen from ITV Wales?
The risk,
but I'd like you to touch on.
Well, as I said to you earlier on, you can't tell because we don't have the baseline data. We don't know what is the dose currently received by people in South Wales. That's the important thing. And then you can add on the CFAS calculations, which are only modelled. They're not empirical. They're only hypothetical. You can add them on top of the dose that local people are receiving in South Wales. Now, what we're being told at the moment is that the only dose that they have to worry about is the dose from the mud. And they've got their calculations of it by their basis, having monitored only 3 of the 50 plus radionuclides, which are man-made coming out of Hinkley into those sediments. They say the dose is very low, but they don't know what they're going to add that on to here. So we got no idea. That's my point about that particular issue. We've got no idea of what the health risk is, because the health risk is what have you already got, plus what is the proposal going to add to you. We don't know. We have no data on that. So you can't officially calculate the health risk.
That's the main issue for me, because there have only been five samples below 5 centimetres. That was back in 2009, and the data no longer exists. It's not there.
They've thrown it away.
Retest. I think that's a very reasonable thing to say. Retest, and I think that's the message which I want to send out there.
What I can say is that I've received 28 spectra. I received the raw data he asked for, and I got the raw spectral data that CFAS produced in 2013 and 2017 from the surface. And what that shows is the presence of these alpha-emitting substances. It can't tell us whether they're in the form of particles, but they almost certainly are. But it certainly shows that they are there. And you will not get anything like that in a banana or in your garden.
Okay, Martin, Media Wales.
Yes, I mean, just to explore the testing a little further, if they did agree to do the tests, obviously one would look at the results. Is there any circumstance in which the results that came back would lead you to change your mind about the dangers?
If they did particle testing and there were no particles there, I would change my mind about the dangers. Yes.
Okay, I think that's a really good question to end on, because what we're saying is if they test and there are no particles, then the objections will cease. But they're not testing, and we need to make sure that they do. So thanks a lot for coming today.
So just